Hello, today we'll be going over problem 1.58 from Griffiths Introductory to Electrodynamics, 4th edition. In it, we're asked to use Stokes' theorem for this function, v vector is equal to yz hat, using the surface triangle shown, and it gives the answer a squared. Okay, so let's write out Stokes' theorem. So Stokes' theorem goes as followed, where we have a surface integral, and we're taking the curl of the function across a surface dA, which is equal to the path integral of said function dl vector. Okay, so we can first start off with the left-hand side and begin with the curl. So the curl of v vector is x hat, y hat, and z hat, and the partial derivatives of x, y, and z respectively. And now the function. This is only in the z hat, so x and y components are 0, and all we're left with is y. Okay, going through, all we get out of this is simply x hat. Awesome. Okay, now, so this is our curl. So plugging this back into the equation, curl cross v vector dot dA integral of x hat dot dA integral dA of x is equal to ax. Okay, so now that we found which area this is, we can now locate it. So it would be the area that is orthogonal to the x-axis, so this shaded triangle right here. And all we got to do is simply find the area of said triangle. So just redrawing it. One moment. It won't be to scale, of course, but I like having myself another image to work with here. So side A, 2A, use the equation for the area of a triangle. So 1/2 base times the height, 2A times A. 2's cancel out, a squared. Awesome. Okay, so now that we've found the solution for the right-hand side, we can now start to do the left-hand side. And there's an easy, something little clever that we could do that we can eliminate one of these sides because it doesn't include the the z hat direction, which would be this side length. So all we have to do is just try and find the path of the zx and zy axes respectively. Okay, so now let's find the solution for the zx axis. So I have my small little triangle here. This will be our origin right here, so 0, 0. This will be, we'll make this the x-axis right here, so a comma 0. And up here, line, this will be 0 comma a. And breaking it up like this, we can now use the equation for a line. So let's use the slope. So going a minus 0 to 0 minus a, -1. Keep on going. So z minus z naught is equal to m x minus x naught. Substitute it. So z naught is a, in this case, equal to m. And when z is equal to a, that means x is 0. So like that. Continue on. Z minus a is equal to mx. Z is equal to mx plus a. M we know is -1, so just replace that in there. Minus x plus a. And we can go back to the equation that we are given. Okay, so now going back to the equation, I know my v vector is equal to some y z hat. And I'm going to dot it against the dl, where dl is just the infinitesimal length or path, so dx x hat plus dy y hat plus dz z hat. And dotting these together, well, the only thing I'm going to get back out after dotting these is that dl. I'm going to get y dz. Okay? And this is equal to 0. So y is equal to 0. Y is constant. Okay, moving on to the next one. So now we can go along the zy axis. Let me again make my triangle. Z. We have y. Try making this to some scale. Again, I'm going to go only with 2 coordinates like I did prior. Z, y. This is 2a, 0. And again, origin over here. Okay, going about it similarly, slope a minus 0 divided by 0 minus 2a, negative 1/2, z minus z naught is equal to m y minus y naught, when z is equal to a, m naught is 0, y minus 0, z minus a equal to my, where m is negative 1/2. So y is equal to, moving the 2 over, minus 2 times z minus a. Okay, that's better. Because now when we do our integral, minus 2, we're going from 0 to a of z minus a, parentheses, dz. Okay? Equal to minus 2 of, let me put these in brackets, z squared divided by 2 minus a z, 0 to a, okay, minus 2, parentheses, plugging in a squared divided by 2 minus a times a, and everything else goes to 0 when you substitute in 0. So this is minus 2, parentheses, a squared divided by 2 minus a squared. So minus a squared over 2. Cancels, gets rid of the minus sign, leaving us only with a squared. Awesome.